Hello, everybody. I'm Vidya Srinivasan. I'm the General Manager for Amazon Redshift, and I've pretty much been with the service since its launch. In fact, reInvent is super special for us because 4 years ago, 2012, is when we launched Redshift at the very first reInvent. So now we are at year 4, and it's just been a fantastic year for the service. We still continue to be one of the fastest growing services in AWS. And more importantly, we're also seeing customers continue to use the platform in really innovative ways. They're really trying to figure out how to drive analytics to drive their business. And essentially what that means for us is we get to get these really crazy requirements and work on very interesting things. So it's been a fun year. So today I'm just going to talk about two major things. I just want to go over the use cases that we see that are very popular with Redshift. And the second thing is I want to do an overview of some of the new features that we've put out this year. I don't think we'll have time for all the features, but at least the ones that I think are very popular with customers. Okay, so before I actually go into Redshift, I'm going to take a moment to give you a brief overview of the Big Data Portfolio. I apologize if you've seen this chart in other presentations. We tried to first position services. So if you think of any big data application, it typically has 3 phases. There's going to be an acquisition phase, which is collection of the data, followed by storing, and then finally analyzing this data. So for the collection portion, we have an array of services. These are just the ones that we see most commonly used with our customers. So if you're interested in the most low latency, high bandwidth connection, basically connecting your data center to ours, Direct Connect is the best option. Snowball essentially allows you to FedEx a whole bunch of data, tens of terabytes of data to us. And then we have Amazon Kinesis, which is a set of solutions that allow you to just stream data into AWS. So these are very popular with IoT devices. And Kinesis has also announced facilities where you can do real-time SQL analytics as well as Firehose, which is essentially managed Kinesis that is optimized for getting data into S3 and Redshift. Again, I see that quite a bit with Redshift customers. The second pillar here is about storage. As you're probably aware, S3 is our foundational storage service. It's scalable, cost-effective, and at 23 cents per gigabyte per month. It's a pretty good place to get your data in, especially given durability with the 9 nines of durability. We also have Glacier, which is a sister service to S3 that's really more for archival. So think of Glacier as your tape drive equivalent. And then we have a couple of managed services for search, DynamoDB, which is a NoSQL data store. It's really used with both key value pairs as well as JSON data for high throughput applications. And then finally, we have the Analyze pillar. And we have services such as Amazon EMR, which is managed Hadoop, Spark, and open source big data distributions. EC2, which is our foundational compute service. And we see customers build a lot of analytics apps right on top of EC2. We have Amazon Machine Learning, which is managed machine learning that is targeted both for data scientists who want to build machine learning models as well as consumers of this model, followed by QuickSight, which is our BI visualization service. And then we have Redshift right there, which is our petabyte scale data warehousing service. Now, to sort of tying this stuff together below, we have data pipeline and data migration service. These are essentially allow you to bring data in. All right, so let me just quickly take a step back. As you can see, we have made a lot of investment in this area of big data and analytics. And really, why is that? Why have we gone all the way, and why did we have services like Redshift? I mean, the key underlying reason is what we notice is there is a huge and widening gap between the data that's getting generated and the data that is getting analyzed in systems like Redshift, or any data warehouse for that matter. And when we took a look at it and said, okay, what's the reason for this? Obviously, people are generating this data. They have chosen to store this data. why would they not want to do something with it? What we found is the legacy systems that were available did not allow for that to happen, either because they were too expensive, they were just too hard to manage and complicated. And as data scaled to petabytes or more, these systems just did not work. And so it was just not feasible to do this in spite of having all of this data. This was really the motivation for creating Redshift. In fact, the goal for Redshift is to come up with a fast, simple, and cost-effective solution, which is a petabyte-scale data warehousing solution. And our offering basically allows you to store a terabyte of data for under $1,000 a year. So pretty compelling. So we've now had 4 years with Redshift in the market. It's not new anymore. So we have a lot of examples of actually customers' usage and what they think about the service. So in this case, for example, we have Boingo Wireless, which has over 100 million hotspots worldwide. And they've moved their data warehouse from Oracle Exadata, and they saw up to 180x improvements in performance. When it comes to ease of use, the most common pattern I see with customers is when they move to a platform like Redshift, they're now able to really unleash their data. Essentially, just open it up to the organization and let people literally just have at it. Vivo, for example, which is an online music streaming platform. In fact, they're quite popular on YouTube if you're into music videos. They apparently drive 20% of YouTube traffic. They do their analytics on Redshift, and moving there really allowed them to create custom dashboards for all their employees. Pretty powerful stuff. The third thing is around cost. I mean, number of customers, couple of quotes here, Financial Times, Hotlook, which is an online part of Nordstrom. People have seen pretty huge gains in terms of finding a solution that is far more cost-effective. So at a high level, who are the guys who actually use Redshift? Well, it's kind of all over the map. I mean, we have people who are in the small to hundreds of, small terabytes to hundreds of terabytes, all the way to customers like NTT Docomo, who are currently pushing 10 petabytes. So pretty large. We also have customers all across different verticals. We have folks in mobile, healthcare, financial services, etc. One of my largest customers would be Amazon itself, the retail and digital wing of Amazon. And they actually store all their clickstream data in Redshift. So if you're shopping in Amazon.com, everything that you click makes its way hourly into Redshift. And they look at this data for figuring out user behavior, for figuring out engagement, stuff like that. A more recent addition to this has been, within Amazon, has been Alexa. So the Alexa team now takes all the interactions that people have with Alexa, and they get moved into Redshift every day, hourly. And one of the fun facts that the team shared with me was they've been analyzing this. I mean, this is hundreds of thousands of transactions or millions of transactions a day, right? Rows a day that gets in. And what they have found is, on an average, almost every day, about 5,000 people profess their love for Alexa. So, yeah, pretty lonely place to be. So that's just the cross-section of customers. Let me then talk about sort of the data use case segments, the high-level segments, and there are really 3 of them. The first segment is around traditional data warehousing. So these are workloads where people are moving from traditional on-prem systems. And there are a couple of characteristics that's important that I think Redshift fulfills for these workloads. It's around ease of migration, security, and ecosystem. These are important things. So with migration, we actually now have another comprehensive offering around data migration service and schema conversion to ease with that. In addition to that, we also have built out our own professional services team that helps customers move over. On security and compliance, well, we'll talk about this in more detail, but we've always viewed security as a first-class citizen, and that's something we built in right from day one. We were lucky that Redshift is Postgres compliant, as well as it has standard JDBC or DBC drivers. And with that, we're able to really work closely with, just work almost seamlessly with a whole host of BI and ETL tools. We also spend a lot of time with our partners. I mean, if you ever visit the Redshift partner page, we have a large number of them whom we work with closely to ensure that as we change and they evolve, things still work for our customers. The next segment is around log analytics. And here I really classify this as the use case where the data is actually machine generated. So it could be web logs, things that are coming in from IoT devices, but essentially it's a large volume of data that pretty high velocity as well. And the requirements here are around being cost effective, fast, and sort of near real time, because decisions get made pretty quickly in terms of what the data is pointing to. So in this case, I think around, we talked about the price point. Around fast, I mean, if you think about the architecture for Redshift, we are MPP, columnar, it has compression enabled, we use zone maps. I mean, all of these different things essentially allow us to process queries very efficiently. That leads to pretty good speed ups, even with 10-way joins. So it fits pretty well. Lyft is a big use case here. They use Redshift for all their rider information. And essentially, they were able to analyze their data in Redshift to figure out that during rush hour, 90% of rides actually share the common routes. And one of the outcomes of this was coming up with the Lyft line, which is their pooling service. So again, it really leads to how the businesses view what they're doing and what they want to do moving forward. The third category and the last one is around business applications. So think of this as SaaS. So this is the use case where customers use Redshift under the covers to drive their analytics platform and what they offer their customers as an analytics platform. In a number of cases, the end users might not even know that it's Redshift below that. And the key things here, the characteristics here around being fully managed, and this is super important because these customers actually run fleets of Redshift servers, not just a single cluster. They want a chargeback model that's easy to follow. And in this case, what I've seen is several customers, because it's so easy to spin up clusters, it's easy, and each cluster it's a single tenant cluster if they choose to do so. They can just charge back based on direct Redshift usage. And the third thing is around just being able to plug into other things that they're doing, because it's an end-to-end platform. Redshift is one node in their entire pipeline, and it needs to work with the step before and the step after. So just having the ability to work with the other tools, both within the AWS ecosystem as well as outside, is important. An example here is how Accenture built its analytics platform with Redshift as one of the underpinnings. So that's about the workloads, right? That's about the types of workloads. The other big trend that I see here is customers are increasingly using us for mission-critical applications. So these are applications that are time-sensitive. It requires that the database stay up, it stays with consistent performance, and be relied upon for making day-to-day business decisions and driving business. And we're seeing a lot of this. Here are some examples of this. One of them I'd call out is NASDAQ, something all of us are familiar with. It's the exchange, and basically they process all their transactions and do daily reporting using Redshift clusters. And super critical to get these out to their analysts in time. So as far as availability of Redshift goes, I mean, as you probably noticed, we are growing pretty aggressively in terms of region expansion. Redshift is viewed as a core service for AWS, and we intend to be in every region that AWS goes to, and currently is, and that's what you're seeing here. We have, I think, 14 regions and counting, so quite a few. All right, so now we get to the interesting bits. So let's sort of talk about some of the new features that we worked on. some of the earlier description is really to give you a sense for why we are building what we are building. I mean, all of this is really driven by customer requirements and what we hear. And so the fact that we are having mission-critical applications guides us towards making sure we are better on availability and things like that. All right, so the first big investment we made this year was around improving Redshift performance. And let me just define what we mean by performance, because it's kind of an umbrella term. We basically said, are there customers out there who are having pain points, and how can we help them move the needle on that? So we view performance on two axes. On one hand, there is the overall throughput of the system, which is how many queries can you process in a given Redshift cluster in unit time, so queries per hour for a given cluster. I think the second aspect of performance that's super meaningful is, are you able to have an interactive experience with your Redshift database? And this is important because when we actually sit down with customers and talk about what they need, if they're having pain points in this area, it really comes down to, hey, I want to make sure I can process all my work, and then there are a set of queries where there's somebody waiting on the other end for this thing to process, and I just need them to be able to get their job done. So it really boiled down to interactivity and throughput. The other aspect that we realized was customers are running Redshift in increasingly open environments. So these are environments where essentially there is no gatekeeper to your data warehouse anymore. They pretty much just set it up and say anybody can go submit whatever they want, and the service has to kind of self-manage and protect itself. So that was another guiding principle as we tried to figure this out, because we wanted to make sure that the cluster can automatically protect itself, because you're going to have users who know how to write SQL and those who don't, and you're going to have misuse of cluster resources as well. So let me go into some detail with that, but before that, a note on vacuum. So we did hear last year that vacuum sometimes becomes a pain point for certain large tables, and so we've put quite a bit of effort on that over this year. I think a couple of weeks ago, we released a big improvement to vacuum performance for both vacuum full and vacuum delete. We are seeing on an average about 10x improvement with performance, and we are seeing up to 100x in some cases. So hopefully that should help in those cases. And essentially the underlying change was we went to a very incremental model of vacuuming, and that's what led to the performance gains. Okay, so I'm going to go a little bit deeper on how we got the 5x improvement in performance. Before I do that, let me just explain sort of the flow of the query itself, so I'm able to talk about this. So in this diagram, what you see is the leader node. If you're familiar with workload management within Redshift, it basically allows you to set up queues, and for every queue, you can set up a certain number of WLM slots. These are essentially execution slots that convert to resources. In this diagram, there are two queues. Q1 has 4 slots, and Q2 has 2 slots. The black things that you see standing in the queues are the queries. The height of the queries, or the height of these rectangles, show the expected query execution time. So the longer it is, the long running the query is. So here you see the query coming in from a BI app, getting to the queue. It gets directed to the queue based on settings if there are some, or it goes to a default queue setting that we would ship automatically. And then it waits for its turn, gets executed, gets a slot, and then stays on that slot for the duration of the query execution. Once it gets there, we actually do the query planning, come up with the code generation, ship codes to all the compute nodes, and the query actually gets generated within the compute nodes, or gets executed within the compute nodes. Okay, so the first change, it's not out yet. So there are a bunch of items here that have the tag coming soon. The expected horizon is about 1 to 2 months. So the first thing here is what we call short query bias. In this case, what we essentially did was, the goal is to basically say, the interactive queries tend to be short in nature, and users don't always know which ones they are, and they can't really queue them appropriately. So we said, okay, we have to figure this out on behalf of the user. So irrespective of what queues the queries land on, we will detect the queries that we think are short and automatically bump up their priority to the front of the queue. And this, overall you'll see that this leads to better throughput because the short queries get ahead. It doesn't get stuck behind the long-running queries, and it's able to improve overall throughput of the system as well as the interactivity. The second thing we did, again, for the same use case, is what we call the power start. Essentially, in this case, every new query that gets to a compute node gets a bump in resources. We give it some extra resource and say, OK, see if you get done, so that you can be out of the queue and out of our slots. And of course, even in this case, the short-running queries will actually just finish and leave the queue, while the longer guys will get swapped out. And really, the trade-off here is, a query that takes 10 seconds or 5 seconds, you don't want it to wait behind one that takes 45 minutes. You'd rather move it up front and have the one that would take 45 minutes take 48 minutes, because it's unlikely to actually matter. The third thing we did was queue hopping. This one's already available. In this case, essentially, we give you a mechanism to specify a timeout per queue. So you can say, hey, in this queue, I don't want any query to hang out and execute for more than 1 second or 5 seconds. And the next queue could be a minute. And the third queue could be an hour. So essentially, you're guaranteeing that the longest time a short-running query will wait on a particular queue would be the queue depth times the timeout that you're setting. So it gives you a sense for getting things done and without knowing a priori what that's going to be. The other big feature that's coming in this area, and I'm actually going to go to the example first before going to the semantics, is query monitoring rules. You can think of this as queue hopping on steroids. The goal for this feature really is to help you protect your cluster from misuse. And the secondary goal for this feature is to allow you to detect those situations where your schema is misaligned. So either you have data skew or you have some kind of IO skew. It will help you recognize these things as well. So what you're seeing here is the Redshift management console. This is not out yet. This is what you'll see when we actually release the feature. So here there is a queue, and for that queue, we'll now allow you to set a bunch of rules. Every rule is really a combination of Boolean expressions. And so the poster child example for this would be to say, hey, in this queue, please identify the queries that spill to disk. So if it spills a terabyte to disk, I think I have a problem. Or identify those queries that are just taking a really long time to run. So in those sorts of situations, you just set up these rules, and then you can specify an action. We currently have 3 possible actions. You can either log that this query happened, and these were the parameters for the query. So you can go back and investigate what your query patterns are and whether it's in line with your schema. You can hop. You can basically move the query to a different queue, or you can cancel the query itself. So all of these things together help you manage your workload and manage runaway queries pretty tightly. And this particular one also gives you a lot of information about the data access patterns. So let me go back to the other slide. So really the format for this is going to be if rule, then take action. The rule itself breaks down to any one of 14 metrics that we'll give you. This is stuff like CPU time, rows scanned, even join count. We are looking at the ones that are leading to Cartesian products and nested loop joins. And then the action is either hop, log, or abort. So pretty powerful if you want to go all the way and really control what's happening. Okay. So that was about performance. Now I'm going to talk a little bit more about ease of use. Again, this is one of our founding things that we wanted to drive into the service right from the start. Provisioning on an average takes, I think at this point it's taking a couple of minutes, 2+ minutes. We have automatic patching, so when we release a new database, which is about once every 2 weeks, you automatically just get this applied to your cluster with no real action needed. Loads are fairly simple. It's just a simple copy statement to load data. And then we have backup, security, and compression all built in. So they just come there. It does need enablement from you. And so the goal now is we are trying to say, OK, we want minimum management of the cluster. We want minimal user intervention. And the things that we know you should do, we just want to do automatically. We don't want to have to ask you to even enable it. So the two examples here, both of which will be released, is around vacuuming and compression. I mean, vacuuming is a necessary operation. Basically, what a vacuum does is it gets rid of deleted rows and it resorts your columns. Now, you can say, why do you even need vacuum? But you get tremendous performance benefits from sorting your columns when it comes to joins. So our goal is to sort of get vacuum to the point, something the way garbage collection works. It's not really to get rid of vacuum and get rid of the performance benefits we get from having sorted columns. So with this feature, we're essentially going to, I first talked about making vacuum far more performant. Now that we have that, we are now going to make this automatic. So it just happens in the background. We will detect when a cluster is idle and just run vacuum for you. The second thing is around data compression. This is just a good thing. There is really no good reason to not have compressed data. I mean, there are a few column types that might be problematic, but for the vast majority of the data in your cluster, you benefit from having it be compressed, both in terms of performance as well as in terms of cost, because once you start compressing data, you can add a lot more data to your cluster. And so we are going to support automatic compression for tables that are created using create table as semantics, as well as for brand new tables. And this just happens. And as you know, compression algorithms also evolve over time, and better things come about. And as these evolve, we will automatically update it for you. So that's something that you don't have to actively go and think about. And then here are a set of features that are more along the lines of, I mean, this is from direct customer feedback. These have been what I would say paper cuts or little things that customers have struggled with a little bit as they try to move on. And we just want to have these features available to reduce friction in their migration or use of Redshift. The first one's around localization. So we now support timestamp with time zone. This has been an important requirement. And we also support multi-byte characters, which is super important for pretty much any customer, for table names, for any customer outside the US. We've also added some controls for resource management. Again, this goes back to having an open environment. People now want to have some limits around how much access or how much usage an individual user can have within an enterprise so that they can control costs. And so we've announced we launched support for connection limits. So you can say a single user can only have so many active connections at a point in time. And then with query monitoring rules, that's another way for you to queue queries from users, because you can queue based on user group and set rules for that group appropriately. The third feature is table level restore. This is a feature where essentially you can point to a Redshift snapshot, backup, pick a particular table and just restore that single table. This is very handy when, say, you've accidentally deleted a single table. You don't have to go back and restore the entire cluster. You can just restore that particular table. With respect to ingestion, it's really more around migration. As I mentioned, we launched AWS DMS earlier this year. I think it was March this year. And it's been, we've had a lot of adoption for that service. We already have support for, so there are two parts to it. There's a schema conversion tool, which basically just converts the schema from source format to Redshift. In this case, we already support Oracle, Teradata, Netezza, Greenplum to Redshift, and we're going to support the other two shortly. And then the database migration service, which actually moves your data along with change data capture. And again, you can read the stuff that we support and the ones that are, and more engines will be added over time. So these really accelerate. I mean, this is a new service, and we are rounding out some of the features there as well. But this, along with some help from professional services, has really accelerated migrations for us. So early on, I mentioned about mission-critical applications being run on Redshift. And what that essentially means that availability becomes super crucial for us. I mean, durability, availability is kind of bread and butter for databases. It's nothing new. And we've had a lot of features in this area. But we are investing even more here. So what do we have? Let's just quickly go over what is the durability model for Redshift. So every time a piece of data lands in the cluster, it gets 3 copies. There's a primary copy. We store a secondary copy within the same commit scope within the cluster. And then a third copy is asynchronously sent to S3 as a backup. And once it gets to S3, it has the durability characteristics of S3. We also take continuous, automatic, and incremental backups. So even you just have to set up a backup retention window. So you can say, I want a backup for 3 days versus 20 days, whatever it is. And you can even take a snapshot of your backup and store it for whatever period of time you want. And the backups can, in fact, be shipped across regions. So by just clicking a checkbox, we will automatically ship your backup data not just to the local region, but to a secondary region of your choice. And that helps with DR and use cases like that. And the other feature here is around streaming restore. This is a pretty cool feature we did. Actually, it was available at launch. Essentially, what we do is when you spin up a cluster from backup, you can point to a backup and spin up a cluster. The creation of the cluster is just a couple of minutes. And we make the cluster available for querying as soon as the metadata gets loaded. As you can imagine, it's a really small part of the entire data set. So within several minutes of actually initiating this operation, you actually have a cluster that can be queried. Now, granted, the performance is not going to be great because we are paging in blocks from S3. So it will have that bias, but at least you have a cluster that's ready to go. And if you talk of availability, it's really about how we handle failures. When it comes to disk failures, we just handle them. If a disk fails, the data that was on that disk gets distributed across the other disks that are there, and we just keep going. You don't really notice it. When a node gets to a point where there are a certain number of disks have failed, we will schedule a replacement for that node during a maintenance window, and that just gets taken care of automatically. On node failures, so if a node fails, you do have an unavailability window with the cluster because we have to go and get a new node and add that to the cluster. And this is the area that we focused on quite a bit this year because we didn't want any availability impact when a node fails. And then there are software failures, again, that's rolled into the solution that we built this year. For availability zone failures, well, the backups are persisted in S3, and S3 is available across AZs. So if you have a backup and say the AZ in which your primary Redshift cluster is fails, you can spin up a cluster on a different AZ using the same backup. And for region-level failures, if you had enabled cross-region backup, you can pretty much do the same thing. And this works. I mean, it's not a hot type, active type situation because you do have to spin up a cluster, but at least you have the option, you have the backup available, and you can pick it up as of a couple of minutes ago. So let me go a little bit in depth with node fault tolerance and talk to you about this feature that we've developed where essentially if a node fails, your applications can go on pretty much seamlessly as we replace the node in the back end. So the picture that you're seeing here is, this is a Redshift cluster with a Lino node, compute nodes. The orange thing there is a monitoring agent. This basically sits on every node of every cluster and reports on cluster health. So let's look at the scenario where one of the nodes fail. So the top node here has a failure. One of the things that we did was build in a system where we are able to detect a failure, a hardware failure of a node within tenths of seconds. The other thing that we've done is also reduce the time it takes to restart the database to within tenths of seconds as well. Because for this feature to work end-to-end, every operation that goes with replacing a node just has to happen super fast. So in this case, the node fails. We detect that something's wrong. And then, this is the interesting part of this feature, we actually go ahead and park the connections. We hold on to the SSL state, the network state, as well as the application state for all the connections that were active at the time of node failure so that they do not see an interruption. So we hold on to the connection and replace the node in the back end. Once the node replace completes, which is a couple of minutes, the connections are, the queries can start flowing again. At this point, there is an impact in the sense that the queries that you had going on at the time of the replace do have to get resubmitted by the client, but very, very soon we are going to introduce a feature where we will submit the queries on your behalf. So it should feel fairly seamless for your end application. At no point in this whole process is your database ever in an inconsistent state. You always have a consistent copy. You might have to resubmit some queries, but your database is always in a consistent state. So apart from the agents that you see on the nodes themselves, we also have an overall agent that keeps track of every node in the Redshift fleet. So this comes in handy, for example, when the leader node fails. Now, granted, that's very rare given the ratio of leader nodes that we even have. Every cluster only has a single leader node. But if a leader node fails, then our external agent is able to notice that and pretty much kick off the same replace workflow. Okay, so that's about availability. Now on to security. This is the last segment. As I said, we focused on it right from the start, and most of these features here, I just want to give you a current state for security. Most of these have been available for years. So security has three components. There's one about encryption, and we support data encryption at rest in the source, which is in S3. You can encrypt your data in S3. Data is encrypted as it makes its way into Redshift using TLS. And we support elliptical curve Diffie-Hellman for forward security. And then within Redshift, once it lands, we again encrypt your data at a block level. We actually do an envelope encryption scheme where every block of data is encrypted using a separate key. All these keys are encrypted using a cluster key, and then the cluster key is encrypted using a master key. And this is basically to allow you to rotate keys without re-encrypting your data. And also the master key can either be supplied by us using our key stores, or it can be supplied by an HSM of your choice. HSM is a hardware security model, in which case we would have to go to the HSM every time you wanted to access the database to get the keys to go access this data. We use Amazon VPC for network isolation and rely on CloudTrail for audit and logging. So these would be the three pillars for having security, and as you can see, we are compliant with a number of standards, including FedRAMP and HIPAA. But security is a thing that keeps evolving. There are new things, there are new threats and new features, and we continue to invest in that. We've currently announced support for IAM support for loads and unloads. So basically, you used to have to provide a user ID password as part of the copy command. You don't have to do that anymore, because essentially under the covers, we've now associated a cluster with an IAM credential and profile. And so it's possible to now grant your cluster permissions for your S3 buckets rather than give a user ID as part of the command. So that's one feature. This leads to better security, as well as it's simpler for you to do that as part of the copy command and maintain all your permissions through the IAM profile. The second thing is around enhanced VPC routing. This essentially ensures that all query traffic only goes through the customer VPC. It never leaves your own private network. Super critical for customers where where this becomes a compliance requirement. Okay. The other big feature that we're adding, and this has been a very popular ask from our customer set, has been to add support for IAM authentication for. Thank you. For database user. So this basically allows you to pretty much use an experience compatible to single sign-on, where a user is able to sign in to their enterprise directory, whatever directory it happens to be. Active Directory is one of the most popular things we've heard. And we have our own native custom drivers, and our custom drivers would then get the Kerberos token or whatever ticket that establishes the identity of that user, and essentially goes to the IDP to get a SAML assertion for that person. The drivers would then go off to IAM to get the appropriate IAM credentials, and then come to the Redshift cluster to get short-lived credentials so that you can log in for some duration and directly log into the Redshift cluster. So this is super useful because you don't have to manage a separate user ID for the Redshift cluster, separate from all the IAM stuff that you have, and you just have a single point where your corporate directory can now just be used for Redshift access as well. Okay, so that wraps up all the new features. This is just the last slide I have. So I mean, this is a summary of the things that we talked about. I think the critical thing I want to point out is, we've been in service for about 4 years now, and one of the things that I'm most proud about with what my team's done is really the pace at which we've been able to innovate. We've introduced 140 plus features in the time that we've been, and we put out a new database every 2 weeks. It's not an easy thing to do, but it's super powerful because when we have that kind of pace of delivery, we're able to break down big, scary features into small things, and we're able to iterate with our customers as well. So it's super powerful. And really, the roadmap is completely driven by your requirements. These are from conversations we have with you, from your blog posts, angry tweets, and everything else out there. So thank you for that, and we continue to strongly encourage you to reach out to us to give us feedback. All right? I have a couple of minutes left for questions, but thank you.